Hello everyone, Gaza Mutkosh, and I welcome you all to this session on data import and integration. So guys, let's have a look at the agenda for this session. The agenda for this session includes understanding how to connect Excel to MySQL, right? So in the previous session, we have seen, let's say, how to export data from SQL. So in this session, we'll be looking at how to connect Excel/CSV files to the MySQL. So guys, let's switch to the MySQL workbench window. So guys, over here we are in the MySQL workbench. So first of all, I'll be showing you the file that I'll be reading over here. So the file that we have over here is the ship performance, right? This is the data that we have. So I'll show you, not this one. Guys, this is the data that we have. So we have a lot of columns. We have the date, then we have the ship type, then we have the route type. So first step is first of all we are understanding the data, and then we'll load it into MySQL, right? So we have the date, then the ship type, then the route type, then we have the engine type, then we have the maintenance status, then we have the ship speed over ground, right? This is the speed over ground knots. The next feature that we have is engine power in kilowatts. Then we have the in distance traveled in nautical miles. Then we have the draft meters. Then we have the weather condition. Then we have the cargo weight tons. What is the weight of the cargo in tons? Then the next feature that we have is operational cost in the US dollars, right? Next we have the revenue per voyage in the US dollars. Next we have the turnaround time. All right, then we have the turnaround time in hours. And next we have the efficiency in nautical miles per kilowatt hour. Next we have the seasonal impact score. What is the impact of the season on the ship? All right, it's wear and tear. And then we have the weekly voyage count. How many trips is it making per week? And next we have the average load percentage, right? This the last feature is average load percentage. So guys, these are the features that we have. So this is the data that we'll be loading. And let's say we have somewhere around 27337 rows. So let's see how do we import this CSV file into the MySQL. So first let's confirm this is a CSV file, right? Yes, this happens to be a CSV file. So I'll be importing this file in MySQL. How? Let's understand. So I'm using this db1 demo database. Now in this database, I can go to the tables and then right click on the tables and then click on table data import wizard. And once I click on the table data import wizard, then I can browse for the file. The file is ship performance and then click on open. So because we have a lot of columns and we won't be changing any data type, so just click on next. So this is the ship performance, and see, date is considered as text, ship type is text, route type is text, engine type is text, maintenance status is text, speed over ground is numeric double, then engine power in kilowatt is double, distance traveled in nautical miles double, draft meters is in double, weather condition is in text, and then we have the cargo weight tons, this is double, the operational cost is double, and the revenue per voyage is also double, right? Next we have the turnaround time in hours, that is double, then efficiency in nautical miles, this is double, seasonal impact score is double, weekly voyage count is integer, and average load percentage is in double. So these are the features. These are the features that we have. We have a lot of features, and then just click on next, and we can click on show logs, so it will display all the logs that it is importing. So in case we do have some characters that let's say are not encoded as far as this encoding UTF-8 is concerned, so we might end up getting few errors as well. So as of now, this I've imported and then click on next. Let's wait, it will take some time. So guys, as we can see, this is see the data import that the log that is generated, right? It is displaying the log for each and every row that is being imported over here. So because we have a lot of records, so it will take some time. So guys, over here it says finished performing task, right? So import data file finished. As we can see, next over here it is asking click next to continue. So maybe we over here we can click on the next, and over here it says 2736 records imported. All right. So in the CSV file we saw 2737 records. All right. Over here we saw 2737, but that was including the headers as well, right? So excluding the headers, it is 2736 records. So all 2736 records have been imported over here. Let's click on finish. And once we click on finish, let's observe the data that we have. So in DB demo 1, we do have this table. So let's refresh this. And in the tables, maybe what I can do, I can click on show tables. So it will show me the table name with which it has been imported. So if we look at the table name over here, we can see the ship performance, right? We can see the ship performance. So maybe I can write select star from the ship performance. All right, this is what we have. And as you can see, this is the data that we have, right? So we have a lot of columns. So first of all, I'll be writing the columns. Over here we have date, then we have the ship type, then we have the route type, then we have the engine type, then we have maintenance status, then we have speed over ground. So this is speed over ground in knots. All right, this is speed over ground in knots. Then we have the engine power kW. Then we have the distance traveled in nautical miles. Next feature that we have is draft meters. Then we have weather condition. Then we have cargo weight in tons. Next we have operational cost in US dollars. Operational cost in US dollars. Then we have revenue per voyage in the US dollars. And next we have turnaround time in hours. Then we have efficiency in nautical miles per kWh. Then we have seasonal impact score. Then we have weekly voyage count. All right, and then we have the average load percentage. Then we have the average load percentage. So guys, these are the features that we have. These are the features that we have as far as this data set is concerned. So because we do have a lot of features, and we have very long column names, so if need be, maybe we can rename the columns. So let's try to rename few columns. So alter table, ship performance. All right, then rename column. Maybe let's say maintenance status 2. Over here I'll call this simply M status. All right, so this is the first column that I'm renaming. Then I'll be renaming speed over ground knots, right? So this is speed over ground knots to SOGK. So this is the second column that we have renamed engine power. So I'm renaming it because we'll be writing a couple of queries. So the engine power that we have, this is, I'll call it EP, right? Engine power in kilowatts. Next we have distance traveled. So this is simply distance in kilometer. All right, next we have draft meters. I'm not changing weather condition. So this is simply going to be weather. Next, after weather condition, we have cargo weight in tons. So this is cargo weight. That's it. Then we have the operational cost, so OP cost. All right. After the operational cost, we have revenue per voyage. So this is going to be revenue per voyage, right? So this is revenue per voyage. Next, we have the turnaround time. So as far as the turnaround time is concerned, this is going to be the turnaround time, and the turnaround time over here is going to be TAT, and this is in hours. Then we have the efficiency. So as far as this efficiency is concerned, this is going to be the efficiency, right? So efficiency for the nautical miles, and this is per kWh. So after the efficiency, we have seasonal impact score. So we have a lot of columns to rename. So as far as the seasonal impact score is concerned, I'll be writing seasonal impact score. Then we have weekly voyage count. So this is the weekly voyage count. So let's call this VY count. All right, this is weekly voyage count. And the last column that we have over here is average load percentage. So these are the columns that we have renamed. Then we'll be solving a couple of questions. So this is ALP, all right, AL percentage, average load percentage. So guys, now we have renamed a couple of columns. So now let's start this. This is the ship performance. All right, this data that we have is the ship performance. So let's see this. So now we have the date, ship type, route type, engine type, let's say maintenance status, then SOGK, EPKW, distance kilometer, draft meters, weather, cargo weight, operational cost, revenue per voyage, turnaround time. Okay, turnaround time in hours. I think I missed this. This was missed. Turnaround time hours. So I'll rename this. Okay, this is spelling mistake. This is around. Let's run this. So now it has changed. So the turnaround time should be changed, right? So yes, the turnaround time is changed. Then efficiency and the seasonal score, let's say weekly voyage count, and then average load percentage. All the columns have been renamed. So based on this data, let's focus on a few basic analysis. So first would be count of different ship types. So what would be the count of different ship types? Over here I can say select count, select ship type wise count of ship type, and then let's say from the ship performance, and then maybe we can write group by ship type. All right, so this is what we have. So maybe we can alias it as the count of ship type. So this was the, let's say, very basic analysis. So the container ship, we have 635, fish carrier 653, bulk carrier 669, none is 136, and tanker is 643. So this is the first let's say problem that we have solved. The second that we have over here is what is the maintenance status, right? So let me count maybe maintenance status, ship type wise count of maintenance status. Let's check this. Next is ship type wise count of maintenance status. So how do we compute this? Over here I can write select ship type and M status. M status wise count of M status as count of maintenance status, and then from the table name that we have over here is it is ship performance, right? From ship performance, and then maybe I can say group by the ship type and the M status. So let's run this and check. So guys, for each ship type, and maybe then I need to group it by order by the ship type. So let's run this and check. So guys, over here for bulk carrier, we have the status as critical, fair, good, and none. So these are the records. And then for the container ship, we have let's say for container ship we has 212, 196, 196. For critical it is this. For fair, critical, good, and none. For fish carrier, again we have these records. For let's say then for none we have these records, and then the last is tanker, so we have these records. So maybe we can sort them. So order by ship type, and then count maintenance status in the descending order. So for each ship type, this is in the descending order, right? The count maintenance status is in the descending order. So now we are getting the desired result as was required by the problem statement. Next, let's observe the data and try to solve few other questions. So we have observed the ship type, then we have observed the engine. Okay, let's observe engine type wise average efficiency, right? So we do have efficiency, let's say efficiency, nautical miles per kilowatt hour. So what is engine type wise efficiency? I want to know. Find engine type wise efficiency. Engine type wise efficiency I need to compute, right? So average efficiency, engine type wise average efficiency. So let's see this over here. This is let's call it the question 3. So engine type wise average efficiency over here, first of all I'll be writing the engine type. This is my engine type. Engine type wise average, the column name that we are looking for efficiency. Average efficiency in nautical miles per kilowatt hour. All right, as efficiency. I'll call this as average efficiency. And from the table, ship performance, and let's say group by. So I'll group it by the engine type. Over here, I'll group it by the engine type. So guys, this is the average ship performance. So this is the average efficiency for each engine type. So clearly the most efficient being is the none one. All right, so we in engine type, one of the engine is none. So that is generating the highest efficiency. So over here, maybe I can order it by the average efficiency in the descending order. So this is what we have, and maybe if need be, we can round this off up to 2 decimal places. So now it looks much better. Okay, maybe up to 4 decimal places. All right, so this is what we have. So this is the engine type wise the average efficiency that we have. Next, if I were to look at a different problem statement, so let's observe the data first. So guys, we have date, ship type, route, engine type, status, then distance in kilometers, right? So maybe we can compute the average distance. Okay, let's go for the operational cost. All right, let's go for the operational cost based on weather and the route type. Operational cost based on weather and route type. Average operational cost based on weather and route type. So over here we are finding the average operational cost based on weather and route type. So over here I'll be writing select based on weather based average operational cost. What have we renamed this to? OP cost as average operational cost. All right, and then from the table ship performance, average operational cost based on weather and the route type. So what is my route type? The route type that we have over here, so we do have different route types, right? So we have none, short haul, long haul. So I'm assuming if it's a long haul, then let's say the operational cost should be high from the ship performance, and then I'll group it by. So this is from the table name, and then I'll have to group it by weather and route type. So let's run this. Okay, so maybe I can order this, order by weather, and maybe I'll round this off. So let's round this off up to 2 decimal places. So guys, for the calm weather, as you can see, for coastal route, the operational cost is let's say uh, like 2,31,975 for the calm, and for the long haul it is 2 lakh. See, for weather, maybe then I can order it by after weather, and then I can say average operational cost in the descending order, right? So the average, the obvious expectation is that for the long haul, the average operational cost would be high. So when the weather is calm, for the route long haul, the average operational cost is 2,67,000. For transoceanic, it is 2,57,000 something, and for short haul, it is 2,53,000, right? For calm, it is 240, 2,40,000 range, and for the calm coastal, it is 2,31,000. For moderate, when the weather is moderate, this was the weather when the weather was calm, the easiest one. Now when the weather is moderate, the, let's say for the short haul, it is 2,70,000. For moderate transoceanic, it is 2,67,000. For moderate, it is 2,61,000. For coastal, it is 2,57,000, but for the long haul, it is less. All right, so strangely, but yes, this is the case. For none, the transoceanic, let's say, fetches the highest average operational cost of 2,89,000. For none long haul, it is 2,58,000. For none short haul, 2,45,000. For none coastal, it is 2,36,000. For the rough, when the weather is rough, all right, okay, this is the highest. The highest that has been was for the weather none. All right, for the weather none, the highest average operational cost was tabulated. When the weather was rough, for the coastal route, the average operational cost was 2,57,000 something. For the when the weather was rough, and for the route, the transoceanic, the average operational cost was 2,54,000. For short haul, it is 2,48,000. For the long haul, it is 2,41,000, and for the rough, it was 2,19,000. Right. So this is what the average operational cost looks like for weather and route type wise average operational cost. Next, maybe we can proceed with another question. So we have date, ship type, then route. All right. So maybe based on date. All right. So let's go for the year and month. Based on year and month, maybe I want to find the revenue per voyage, right? Year and month wise revenue per voyage, and the seasonal impact score. Let's see if we can extract this. So this is question 5. Find year and month wise average seasonal impact score, average seasonal impact score, and the revenue per voyage, right? And I need to compute the revenue per voyage. So year and month, how can we compute year and month? Over here I can write select year from the date as year, and then this is the alias year, and then month from the date as month. All right, and so year and month wise I need to find average revenue per voyage, average revenue per voyage as the average revenue per voyage. All right, and then so this is what we have, and then over here I can compute average seasonal impact score. Next we have the average seasonal impact score, and I'll call this as average seasonal impact score. All right, and from the table name is ship performance, and then I'll group it by year and month. So I'll have to order it by year and month. So this would be year. All right, let's see. So unknown column month. Okay, this is MON. So guys, see, for the year 2023 6, this is the result. Average revenue per voyage. Average revenue per voyage. So it's better if we round them up. So I'm rounding it off up to 2 decimal places, and even I'm rounding this off up to 2 decimal places, right? So this has been rounded off. Then the second one, this I need to round off this one. So guys, this is what we have. See, average seasonal impact score. This is what we have for 2023. It is starting from the 6th month, 7th, 8th, 9th, 10th, 11th, and 12th. And for 2024, again we have data ranging from the months 1 to 6. So average revenue per voyage for each month is nearly same for the 6th and 7th month, but for the eighth month it went up all the way up to 5 lakh, let's say 41,000. Then it went down. So for 2023, the highest average revenue per voyage for all the months combined, let's say for one particular month that was highest was 5,41,000, and that was for the month 8th month. And then beyond that it has dropped. But starting 2024, from the month Feb onwards, it again went to 5,40,000 range, right? The same range and even beyond. And let's say, and then it dropped post the March. And average seasonal impact score. So the average seasonal impact score was less than 1 only for let's say one particular month, that is 2023 7th month, and for all the other month it was less than 7. It's more than 1, right? For all the other months it's more than 1, nearly more than 1, except for 2023 11th, as in the November, and for let's say 2024 6th month, right? Otherwise the average seasonal impact score has been greater than 1. So for a couple of months the average seasonal impact score is 1 as well. So but majority of the values are close to 1. All right, the majority of the values are close to 1. So this is the data that we have, and then we have another significant metric that we have, and that is the last one. The last one is average load percentage. All right, the column that we have over here, we have renamed this, right? So this is average load percentage. So average load percentage, maybe we can check this based on the ship type, right? So maybe this is a simple question again. So I want to find ship type wise average load percentage. So the data is already in average. The data is already average. So maybe I want to find ship type wise what is the minimum and maximum average load percentage. So how can we compute this? So over here I'll be writing ship type wise average. The column name that we have over here is average load percentage, as this is going to be the minimum. So this is minimum average load percentage, and then I need to compute the maximum. So this is going to be the maximum, and maximum of average load percentage from the ship performance. All right, and then I can group by the ship type, but I have to mention the table from the ship performance. From the ship performance, group by ship performance. Okay, from ship performance I've mentioned group by ship type. So most likely I'll have to round this up. So I'm rounding it off over here itself. So guys, this is done. So this is ship type wise minimum average load percentage and the maximum average load percentage. So the minimum, that is the bare minimum, is 50 for each, right? Each ship is let's say bearing at least the minimum average load percentage of 50%, and the maximum is nearly 99 to 100. The maximum is almost very close to 100, right? So maybe we can compute the count as well. All right, for each ship type we can compute the count. Let's say how many values are closer to minimum and how many values are closer to maximum. So guys, this is how, let's say we import the Excel/CSV files into MySQL, and we have seen how to perform the analysis on the same as well. So guys, that brings us to the end of this session. Let's switch to the PPT. So guys, we have seen how to connect in this session. We have seen how to connect Excel files with MySQL In the next session, we'll be proceeding with understanding how to connect Excel files to Postgre. Thank you.